as I told you, so we focus on this picture plant property. So being detailed with the lubricant oil, and this picture shows our natural shampoo. So this is appearance is white liquid, but after dry, so will be transparent. So this key technology is jelly phase that will provide CNA zero to fiber. You know, generally, zero to fiber is hydrophilic, but so we convert CNA to be hydrophobic to utilize our technology. So this lubricant is silicone oil. So this picture shows simply film after wine. So the hydrophobic cellular fiber is a strong retention of the lubricant on the surface. Here is a summary of our product. Lunaflow with environmentally coating agent. The product appearance is narration like this. Effective concentration about 10%. Viscosity about 100 Pascal. And the coating method is such as spray, air spray, river spray, or cloth. So you can coat this product on metal, plastic, brass, and ceramic, and things like that. And basically, this product can be used without dilution. However, when dipping in all these agents for molecular level applications, so using it as it may be consent level and could cause a chemical that's why we recommend dilute with water when using it for different purpose like molecular application. So in the floor, we also see water-based emulsion that is in cellulose fiber. Here is our test movie. So by coating our macro, like this, so it will be white. However, after drying, it will be transparent like this. So polypropylene like this. The left side is this macro here. It's slippery carpet like this. And it's a bad drop. So the bad dropping slip easy like this. It's a small sliding. So many things can be slide and slip to use this technology. So that's why, so as well as resin and rubber application, so we like to utilize this technology to various kinds of industry, like preventing burn application, preventing bacteria application, preventing bad dropping application like this. This is very unique technology from this yeah. So here's the natural release agent. So I'd like to explain the movie so you can the data will release performance and ability compared with silicon-based release agent, including this release agent like this. And by applying the same coating with glass spray, so it lasts for at least 10 shots. Performance summary this product. So comparing with conventional release agent, such as silicon-based agent, fluorine-based agent, so the flow is very good usability and very good environmental property, like fluorine free and water-based. So this slide shows our customers test result in design. So in this customer, so they field test move field state using vulcanized rubber. The test method is here. Apply the mold release agent to the flow to the substrate and allowing to dry the plate by touching rubber from organization. Then to use enough flow, so it can reduce the heat force like this. And this picture also shows the surface of the substrate after releasing the vulcanized rubber. The black portion of the rubber adheres to the surface of the substrate. It may release performance model with silicon-based conventional release agent. With enough flow, it can reduce the frequency of water cleaning. This is the benefit of this agent, enough flow. So this is a test of our laboratory, the comparison with silicon-based release agent. We apply a silicon-release agent with fluorescent labeling to a substrate, and also apply the fluoride release to the same substrate, and then compare the surface before and after resin release using microscope image like this. So before resin release, silicon release agent is here. However, after resin release, most of these agents disappear like this. On the other hand, the flow can keep the surface of the substrate. The flow remain on the substrate side even after resin release like this. This is also benefit. On the other hand, so this is the result of the observing the resin surface side after releasing the resin. So comparing with conventional silicon release agent, so the flow doesn't adhere to the resin side like this. It means the flow remains on the substrate side without migrating to the resin side. This is also a benefit of this agent. And so this is a mechanism of extending performance and high durability. So basically, the oil, this is silicon oil, we at high temperature and heat and heat, and then we can do the film at the screws. So applying the release agent to the slurry glass, heating it, and observing the surface with the laser microscope. So when heating 100 degrees, the lubricant expands because of the high temperature. However, instead of the fiber, good for thermal expansion. So that's why this spherical and this shape, and the lubricant expand a little bit. So that's why to controlling the extent of oil bleeding in response to temperature change, so it achieves more extent release property and durability as a release agent. Here is the result. For your difference, so this may also our lunar flow application use case. So this is a feedback from our Japanese customer. So as for rubber, for example, VPVM and fluoropylene, CR rubber, and FKN, and NR, DR and IR with very good release performance to use lunar flow. However, the silicon rubber is not good. This is because the silicon oil in the flow may migrate silicon rubber, so silicon is very compatible. So plastic, so PPU, thermal polyurethane, and epoxy resin, PVC are very good. However, PVP and plastic is not a good performance. This is because the boiling temperature is very high, 290. So here is the summary of the agent. High temperature lubricant lead from the membrane into the rubber diffusion, and after mold release, cellulose fibers gel membrane remain on the mold side and be repeated. So that's why we can expect really high durable this agent to use in flow. Finally, so we prepare this application note. So we can see how to use this agent and how to handle and after use. So if you test sample, so before testing sample, so you can refer this application note. Okay, and that's all from my side. Thank you for listening.
Thank you very much. Thank you very much, Mr. Manato-san. Any questions to Mr. Manato-san? Is online? Yeah, okay. Yes, okay. Can you pass the mic to the something there? Manato-san, can you hear us?
Yes, I can hear you.
Okay, we have a question for you.
Yeah, Hikida-san. Dr. Solanki this side. Nice to know your presentation. So we understood LunaFlow, this is a releasing agent. So may I know, like silicon rubber is, like not very good as a releasing agent if it is, we are considering in terms of environment. So in your product, since this is silicon rubber, but it is coated with nanocellulose, so how is it impacted on environment?
So your question is impact for environment.
On environment, yes.
Is that correct? So, okay, so environment. So, as in terms of environment, so this is a water phase and the VOC3, the fluorine free. So, in this, basically, so this is like environmental free and environmental friendly. So, does my answer make sense?
Yeah, means the material, like your product, this is coated with the cellulose, and inside of material, is it silicon rubber or means silicon oil or something else?
Yes, exactly. So silicone oil base main ingredient.
Yeah, because silicon oil, yeah.
By itself. Yeah.
Yeah. So, yeah, so my point was silicon oil as such is not good for environment when it is as a drainage, If it is coming in environment, how is it good if it is being used? This is question.
Okay. So silicone oil. So I'm not sure that silicone oil actually good or bad for environment. So that, however, so the product based on water based. So that's why so it will be good environment comparing with solvent. This agent with solvent.
Thank you.
But yeah.
Thank you.
Thank you. Any other questions?
Okay, can you hear me? Okay, yes. If you have more questions to Mr. Manato-san, please write an email to Manato-san. Is that all right with you? Yeah? Okay, so send an email. Can you show your email address so that everybody can see it? Okay, you have on the last slide, I guess, somewhere. Okay. Or maybe all the organizers can provide you his email address so you can communicate with Mr. Manato-san for the further questions, yeah? Join me to give him a big hand, please. Yeah, yeah. Manato-san, we really want you to be here, but thank you for doing an online presentation. Our organizers will send you a nice token of appreciation to you. Is it right? Yeah? Okay. So once again, give him a big hand, please. Thank you very much.
Thank you so much, sir. Since Mr. Manato-san has joined us virtually, I would like to request Cow's distributors, JMF Synthetics, to accept this memento on his behalf. So may I request the General Manager of Bombay Chemical Group, Mr. Vivek Gupta, to please come on stage. And I request Mr. Perum Prasada Rao to kindly present the memento to Mr. Vivek Gupta. On behalf of Mr. Manato-san, Mr. Vivek Gupta from Bombay Chemical Group accepts this memento. Can we hear a big round of applause for Mr. Manato-san? Thank you so much. Now, over to Mr. Rao again.
Okay, the next. Thank you. Okay, the next speaker is Mr. B.B. Sharma, the Technical Director at TWC Group, Techno Waxchem, and Raisha Chemicals. He's going to give a talk on also the TWC Group and the special rubber ingredients. I'd like to read about his profile. He has a long journey with the rubber industry, a well-known, well-experienced guy. Mr. B.B. Sharma is a distinguished professional with a rich and diverse career spanning 45 years in the rubber industry. He holds a degree in chemical engineering from BITS Pilani and complemented by management diploma from IGNOU, and he's honored as a fellow of the Indian Rubber Institute. Throughout his career, Mr. Sharma has accumulated extensive expertise in tires, elastomers, rubber chemicals, and rubber products. He has served in pivotal roles at the various renowned companies like JK Tires, Birla Tires, Apollo Tires, ExxonMobil, Reliance Industry, and the TWC Group. Currently, he is the technical director at the TWC Group. Join me to welcome Mr. B.B. Sharma, the well-experienced rubber technologist. Come on, guys. Yeah?
Thank you. Thank you, Mr. Peram, for the nice introduction which I provided, and you made it very interesting one. Thank you very much. Okay, I've got 20 minutes to cover a presentation. I hope I'll be able to do some justice to my presentation. The topic for me is TWC Group, special rubber ingredients. Now, what I would be making is kind of a techno marketing presentation. I'll try to make it more technical, but I'll do some amount of marketing for my organization. And I'll also launch in the sense I'll brief entirely a new product, what we are offering since about 1 year. And this will be the first time we'll be disclosing that product, features of that product in this meeting. So let's go to the next slide. Okay, I've got, sorry. So we talk about the basic compounding. Now, for all rubber industries, compounding is the main backbone. There are not many people blame any other thing other than the compounding. So the compounder has the main say in the decision or any kind of compounding activity what he has created rightly or wrongly. There will be processing and performance offering by TWC in our group, which is a North Zone. So I'll talk about what all ingredients being offered in this group, this region, North region. And new is very, very special ingredient for low rolling resistance, heat buildup, better fuel economy, etc., and energy efficient conveyor belt tire for natural rubber and carbon black compound. Okay, we know about silica and silent coupling agent, but this is for natural rubber and carbon black. So this topic might be good for many of the solid truck bus truck bus tires makers plus conveyor belt makers. Okay, so that's the kind of thing, and then I'll cover with summary. So this is a slide which shows that, okay, everything is available, what we think about, we are working on rubber, we are eating, sleeping, okay, enjoying life on rubber. So that's basic, difficult to imagine life without rubber. Okay, compounding, the complexity, okay, the list can be very long, but I'll say there are numerous challenges to compounder. He has to handle so many rubber chemicals, differing properties, material, you can have a composite, rubber composite, which could be rubber, textiles, and maybe other solid materials. Specific tasks, the product as a composite has to perform specific, which could be very, very challenging at times, differing conditions, operating conditions, and people find it difficult to compound it to the kind of success of the customer. And also to fulfill the local, regional, and global requirement. Now, be it ISO requirement, be it tire regulation, be it your SVHC norms, etc. All these are to be mandated, and those are being increasingly making difficult life for compounder. And to perform over a longer period, under adverse condition, again, as I said, operating condition could be very, very challenging for the compound, and it's may fail, and that's like if you imagine a heavy load tire in the mining belt going and carrying about 40 tons load against 8 tons. So those kind of challenging scenarios are being faced by tire industry or other industries. And also to optimize resources, which is man, materials, machine, method, and money. Money is the bottom line. The compound cost has to be the lowest. That's ever demanding requirement with the compounder. So we have to manage all this. Some are controllable, some are non-controllable. Like if I say machine are capex, so it cannot be done or made changes overnight. And the special ingredients require almost for all compounds. Now, special ingredients are just about less than 5%, but these are being used by almost all compounders for all the products. Conflicts, again, conflicts are required for physical properties, anticipated attribute processing, but the compound has to process in the plant without defects, without rejects, successfully, with the least energy, etc., and also to perform the dynamic condition of product application. And reinforcing material, which are kind of acting as a composite, these are again a big challenge, because you can't control rubber compound, but the bought out your reinforcing materials can have some inherent aberrations which have to be taken care of. So those are also are to be taken care of by materials like dry bonding agents, etc. Less controllable, as I said, processing machinery cannot be changed overnight, and variability in raw materials, which could be can be controlled, cannot be controlled. Now, purchase less controllable properties we discussed, and the bottom line is the main thing. Like compounding is compounder is the magician. Okay, here the key objective is to satisfy. The compounding key objective is to satisfy fulfill service requirement. So it has to come out and compete with the competition, that to increasing competition, make establish the brand image for the company. So those are the basic objective, and to satisfy better processing requirement, which are internal, optimize power, ensure consistency, and less rework, scrap, rejection, etc. And last, again, the main bottom line, to maintain balance between the properties and price. And I remember one of the multinational company, Perali, which says mixing is like kitchen, garbage in, garbage out. If you don't make the right compound, your product is not going to survive. And another was like, if your compound is good, the product is going to be consistent and it will be with least scrap, least defects. Now, compounding ingredients by our group, which is TWC. So we make specialty materials, specialty ingredients for rubber industry, mostly tire industry and non-tire as well, but mostly tire industry. Offering, if we say all compounds have these 8 categories of material typically. So what are the highlighted one are the one which we say we are supplying. So if I say, I have not marked the cross-linking agents, but we make chemical master batches. So those are chemical master batches where you have what 80% say chemical in rubber batch. So those also we make, but we make anti-degradant waxes, not antioxidants and anti-ozonant, but anti-degradant waxes. We make several varieties of processing aids, which could be homogenizer, peptizers, softeners, mold lubricants, etc., which will aid all kind of processing during right from mixing to product manufacture. Then there are special purpose material like bonding agents or tackifiers or rosins or resins, phenolic resins, which are going to aid the process and more importantly the product in performance. And the two bold one is tread enhancement resin, like okay, for passenger car tires, low rolling resistance had been the demands in last 15-20 years. After low rolling resistance, the demand came that we have to have the traction also met. So accordingly, the tread enhancement resins are the one which are kind of acting vigorously and not being used as a normal resin of 2-3 PHR, but it's maybe 15-20 PHR for providing much needed traction without sacrificing the rolling resistance. So it's a kind of big requirement and very established process being used by people for ultra high performance or high performance tires being used in Europe, where you have tire regulations for PCR tires, passenger car radial, and coloring materials. So there are part of marketing. We have two organizations under TWC. One is Technovexchem Kolkata, which has got 2 plants. We make 11 product verticals. So I'll say verticals of different categories of material, but we say we make about almost 70 odd products in our plants, in 3 plants. So we make resorcinol dispersion, which are resorcinol and stearic acid, etc., resorcinol and silica. We make resorcinol resins, which is resorcinol and formaldehyde resins, RF resins. We have dipping resins for textiles. We have super tackifier resins equivalent to co-resin, which is a super tackifier. We make modified DCP resin for cutting and chipping resistance. We make process aids, various varieties of process aid, which we'll touch base later. We have also done some sustainability